So here we go.
All right, I think we're live. Kerry, are you with us?
I think so. Hope so.
All right, we're going to get started. Thanks for joining us to talk about building a regret-free foundation for your data factory. A couple comments. We'll post these slides if you'd like them on our blog after this webinar. If you're joining us in Teams, there are live captions available for you. There should be a Q&A panel as well, so you can ask questions and we'll pause throughout to try to address the questions. And if there are any at the end, we'll either address them at the end or we'll add a blog post about it when we post our slides. With that, let us get started. For those who don't know us, my name is Meagan Longoria. I've been a business intelligence developer consultant for a long time now. And with me is Kerry Tyler, who's done a lot of stuff, including business intelligence.
And it's funny, I was going to say I have done this for a very long time and kind of leave it at that as well. But yeah, so I've done a bunch of stuff with SQL Server and data, and I've been here for longer than I want to talk about, and that's it.
So we both transitioned from, T-SQL and SSIS into Data Factory as it became more and more popular. And the product has changed since we started using it as well. But as we consult with our clients and talk to colleagues around the world, there are some things that people seem to be making mistakes about that are hard to fix later. And that's what inspired this presentation. What is it that you don't know that you're messing up? So I made a list of the top regrets that we have heard, either that we've experienced ourselves or that we've seen clients struggle with or ask questions about. And so there are about 9 of these, and these are what we're going to focus on today. This is a little bit less exactly how to build a pipeline and more how do I configure things and how do I set things up and use naming conventions and that type of thing to make sure that when I do get into the hardcore development, things will go more smoothly. So the first thing we'll talk about is poor resource organization in Azure. How do you split up your environments? What do you need for each environment? A common thing we see is lack of naming conventions, inappropriate use of version control. We have strong opinions on this subject, but version control with Data Factory is probably a little different than you are used to. And there are some special ways to handle it that may not necessarily be intuitive if you've used it with SSIS or database projects. A lot of people I'm seeing are still doing really tedious manual deployments of their data factories, and there are better ways that just don't take a lot of extra time, effort, or cost. So we'll show you that. There are still lots of people not consistently using Key Vault to store their credentials, and that is bad news for a couple of reasons. And then just a lot of misunderstanding about when you need integration runtimes, which ones are available to you, how you need to configure servers and things for self-hosted integration runtimes. I think the biggest thing I see when anyone first starts in Data Factory is they're just underutilizing parameterization. Parameterization and metadata-driven pipelines are your friend. And it's not, especially if you came from SSIS, that's less true over there. I mean, you can use BIML, but it's not quite the same. So this is usually a learning curve for a lot of people, either if they didn't do kind of ETL, ELT before this, or if they came from a very, a system that's highly coupled to the metadata that it's copying or transforming. And then lack of comments and documentation, partly because a lot of people develop in the user interface, so they can't just comment their JSON code. And then just not having established design patterns. I used to do a whole presentation about SSIS design patterns. The same thought process applies here as well, and may even be more important here. So let's get started on resource organization. We want to have separate environments for dev, test, prod, however many environments you feel you need. And in each environment, you need to have a data factory and a key vault. So you have a dev data factory and a key vault. Maybe if you have dev, test, prod, a test data factory and a key vault. Keep those things separate. I've seen people trying to do dev and prod in the same data factory and it does not work. And I really don't want cross-contamination of my credentials from dev and prod in the same key vault if I can help it. So since we need these separate resources in Azure, we need to have a way to separate our environments. There are 3 just generically common ways to separate environments in Azure. You could do resource groups, subscriptions, or tenants. Tenants is probably the least common, and resource groups is usually the most common from what I've seen. So here's what I mean by that. In your one Azure tenant, you may have a single subscription that contains 3 environments. So you have your dev resource group, your test resource group, and your prod resource group. And in each resource group, you have a data factory and a key vault. And you'll notice down here, I only have one DevOps project across all of those. And we'll get into more detail later, but there is just one project for this. The other way you can do this is to separate by subscription. So you'll still have separate resource groups, but maybe you have other things going on in this dev subscription than just your little resource group. It depends a lot on how your organization has set up Azure, and if you're doing billing, you need to see it broken down in certain ways, or just who owns the subscriptions. So that's what it looks like. And again, keep the same single DevOps project. That's what it looks like for the subscriptions. Tenant was our third option, but we're going to tell you that's a bad idea. So there are just a lot of issues with that. If you try to cross tenants, including managed identities, permissions, users that just don't work cross-tenant, you end up doing some B2B stuff. It's not ideal. It makes it a lot more complicated. So if you can separate by subscription or resource group, you're going to be better off.
And that's one of those things where you might not have a choice. Like, since tenants, I always think of tenants being basically equivalent to Active Directory domains, in an old school or an on-prem environment. And so I've worked in shops too, where everything is separated. Each production, dev, test, all those tiers have their own separate domains. And so if you're in an environment like that, you're kind of probably stuck that way with the tenant divided tiers. But yeah, hopefully you're not.
All right, one of Kerry's favorite topics is next.
Yes,
naming conventions.
Let's talk about naming things, because I love naming things. I'm bad at it, but there's ways around being bad at naming things, which is kind of what we're talking about here in general. So when it comes to under the umbrella of ADF, talking about ADF, there's 2 levels where things get named. There's of course the level of naming things, naming the Azure resources, which is that the data factory itself and things that show up in the portal, and then the artifacts within the data factory itself. Those are all the things. These don't show up in the portal as they're within the data factory. So these are general comments about naming things in Azure, right? This section has nothing to do specifically with ADF. But it does apply, of course. So with naming scopes, every object within Azure has a a scope across which the name has to be unique. Storage accounts are an example where names have to be unique globally because those have public DNS names that need routed, and so those all have to be unique across the world. Data factories actually also are globally unique, and so when you name a data factory, no one else in the world can have the same factory name that you do. Also, of course, these names have requirements. Some of these names have more strict requirements than others. Storage accounts is a good example. Those are kind of short. I think, I don't remember how many. They can't be too long, and they're only letters and numbers, and that's it. Components, when we're talking about conventions, the components that go into the name, this is where you start to make things up and come up with your convention. So a couple examples of those are the first one here is the resource type, the workload or the application tier, or the workload or the application that it services, and then the environment or the SDLC tier, if you want to call it that, dev test, whatever. These are just a couple examples. The main thing here is to do something, right? Don't have a standard. It makes it easy to name things if you're like me and are otherwise bad at coming up with names. If you have a nice standardized list here, it makes it real easy because your names are basically all defined for you. Another note is the names are a little less important these days because we have really good tagging capabilities in Azure. Tags are just open-ended key value pairs that you can assign to any object, and you can even sort and filter by those in the Azure portal. So that's a real nice feature to use if your naming convention has to wind up being really contrived. One thing that you might be thinking about looking at this is like, well, Kerry, why are we putting the resource type in the name? Because if we're looking at this in the portal, the little icon's right there next to it. We know this is a data factory, or we know this is a SQL database. Well, if you were thinking that, that's a great question. And one of the things that we go so far as to say is that it's a good idea to keep your resource names unique basically across the organization. And one of the primary reasons for that is when you use, if you use managed identities to define or to control your access to things, those managed identities, when you create them, basically just take the name of the resource. So if you have non-unique names, those will all show up as the same. This also can be a problem if you use a lot of PowerShell or command line stuff to do your management work. So in this little example here, you see we've got a data factory, a SQL server, and a SQL DB that all have the same name. They're all ADF-deploy demo-dev. The problem is if you create managed instances for these resources, they will all have that same name. And some parts of the UI in the portal, like this little thing on the right here, this is where we're selecting a managed identity to grant access to a storage account. And you can see that both these items have the same icon and the same name. It's hard for us, the human doing this, to tell what's going on and which one is which. Also, likewise, if you're doing PowerShell, when you list objects, they all have the same name. And so it's maybe not difficult to make sure you select the right thing, but it's risky, right? You have to make sure that you are selecting the right item when you're doing your scripting and other work.
And even if you know that you're always going to filter on the resource type, you can't guarantee that everybody else in your organization is going to remember that. So as Kerry said, it's just risky to leave it like this. So go ahead and add a resource type abbreviation into your, if we go back here, into your naming convention. And that will always help make it unique. So you wouldn't run into this data factory SQL Server database always having all having the same name rather.
And I know that's kind of crappy because like you're burning characters in your naming convention, especially like I use storage accounts as the example of something that's got a short name requirement. You're burning characters to do that, but it's worth it because you'll hurt yourself a lot less.
Yeah.
Yeah. Moving on from Azure level resource naming to talk a little bit about naming for the artifacts within the data factory itself. when you name these things, use an abbreviation for the artifact type at the beginning. That saves characters and makes it a little easier to read. Here are a few examples. We've got a link at the end to an article that has kind of a nice proposed standard, if you will, for basically every artifact type in ADF, a little abbreviation to use for those. As part of the name for, like, say, a pipeline, the pipeline should indicate what they do. Include that there, so it's real easy as you're looking through things or selecting which pipeline to edit, so you know which one you're grabbing. And likewise, other objects in there too, databases and linked servers should indicate what they do, the type of data the type of data that they contain, and then what that data source is for, or what the subject of its data is.
Yep, and this becomes even more important when you're deploying, and we'll talk about deployment in a bit, via like PowerShell code, things like that. But it's still useful in the user interface in the Data Factory studio. So it'll make sure that my pipelines line up. They're already in a folder together, but the like pipelines that all do copies kind of go together, or the ones that all are part of a specific project, depending on your naming convention. Same thing with data sets. My linked services line up as ls underscore SQL underscore whatever the data source is. Then I get all my SQL stuff together. And maybe it's just nice organization, but if you're deploying via code, you can do wildcard things, because in the backend, even if you use the GUI to create all of these artifacts, they're all just JSON files. There's nothing, a pipeline is a JSON file, a data set is a JSON file. So if I can do wildcards and say, give me all the pipelines, because all of those files start with PL, then it seems kind of, hokey, but it can actually be really helpful. And when you're looking at it outside of the source control folders or outside of the user interface, it really helps organize things.
And that applies even up at the resource level too, even up in the Azure portal, right? It might sound hokey to think about how things are sorted in the UI when you're looking at them, but that can really help with your sanity in some cases. Quick example here, what this looks like. Like you can see all of our pipelines here. Yeah, as Meagan mentioned, they're organized in sections, right? So there's pipelines and then data sets and data flows on down. But this makes a nice way to show, keep track of what does what. And you can see here, right, the executor PL has, or pipeline has PL exec in the name, and it's real easy to tell what these do just by looking at their name, which is great. And anything resembling or anything beyond a demo environment like this that just has 3 pipelines in it.
Yeah, mine was a little simple, but I think you can get the point here.
Get the idea.
Yep. So that takes us to version control. Version control is sometimes unintuitive in here, but here's what we recommend. One project for all of your data factories, and your repo is connected to development. And Kerry bristled at this the first time we discussed this, but there are issues with multiple repos depending on how you set it up. So what we mean by multiple repos is, like, let's say you have dev test prod. You have a repo for dev, a repo for test, and a repo for prod. And some people think that's a good idea for disaster recovery kind of purposes. In case somebody goes and makes a change in test and it doesn't get pushed back, or a deployment goes bad or something, and you want to have the most recent thing readily available. But there are other ways to handle that. And especially if you're going to use DevOps pipelines and do JSON file deployment, it actually makes it harder when you have multiple repos. But in any environment, you can always capture the ARM template really quickly, either through code or manually. And I actually I hadn't thought to try this, so I was kind of impressed someone did it. I saw in a client environment, they had like a dev and a prod data factory, and they were connected to the same repo. They basically tried to use branches, so a dev branch and a prod branch, and it didn't work very well. So they were asking me, well, what do we do? And so generally the guidance right now is have really good DevOps processes, and we'll show you some of the deployment things that we like, but have the repo connected just to development, and then make sure your changes always get moved forward as they should. So here's kind of, you need to pay better attention to branching when you work in here compared to many other ETL tools. My opinion is that you should always have two permanent branches. You have main and you have integration. And when you're actually building stuff, you build in short-lived feature branches. And I actually mean short-lived, like they live for your sprint while you're working on that one individual feature. I have many times walked into somebody's data factory and they've got a branch that's been alive for like 6 months. And it's so far from what main is because somebody else has gone in and deployed, 2 sets of features, and they're so far different that you have to just manually like compare files and make sure you've got all the right stuff and that the new stuff didn't change anything that breaks there so that we can get everything back to a cohesive working state. So seriously, short-lived feature branches. Don't let them remain through multiple deployments if you can help it, or you need to be really good about merging from main back into your feature branches a lot. I guess either way is fine, but I would say, short-lived feature branches and try to avoid even having to merge main back into your feature branch. That's not always possible, things happen, but I feel like that's the easiest way to go. So you can have, 5 different feature branches if you've got different things going on. And once you have one of those branches complete, you've unit tested, you merge that into your integration branch. And that way you can run it alongside all the other stuff that was already in main. And when you feel like it's good, you pull requests to main. So my philosophy is let developers merge while they're in this dev data factory into any branch except main. Main is special because it should always contain the code that's about to be deployed to the next environment. We don't let junky, non-working, non-tested code in main. So that's why there's a pull request there. It's kind of our gate. So here's what that looks like. We start from main and somebody's going to develop a new feature. Maybe 2 different developers are in here and they're working on separate features. And they decide they're going to have one release. So they each do their features and then they each merge into integration. And once they feel like it's pretty well tested, they pull request into main. And you may not know, if you haven't worked with Data Factory a lot, there's actually another branch in there, and it's called the publish branch. If you look in your source control, you may see it called ADF_publish, I think. So that branch represents what is actually in the service, what has been published to the Data Factory service. The other things are what is in source control only, essentially. The publish branch is where you can ad hoc trigger or schedule trigger your pipelines. Before that, when you're testing in your feature branches and integration, that is done via debug. So something like this, I mean, you can decide your exact process, but communicating this process up front so everybody involved in development and DevOps understands this is the important part.
One other comment I'll make here, since if you've been on a team of more than, I mean, I'm pessimist about this sort of thing. If you've been on a team of more than you working on the same SSIS stuff, you know that, or you're terrified when, when Meagan says merge or about this stuff, you may be like, there's no merging going on. The good news is that in the olden days, right, with SSIS, that was, I always just say it's impossible and you can't do this. And, you have to just talk to each other to develop things at the same time, in parallel. But with this, since everything is JSON, the merging over here between the feature branches into integration, it's a lot easier because everything is JSON. It's not necessarily, as good as merging C# together necessarily if you've got a bunch of different things going on, but it's a lot better, or I at least find it a lot better to like code review stuff and merge things together with ADF in this type of environment than it was with SSIS. I may be weird in that, but I just anything here with JSON when you're looking at the source is a lot better than trying to, let VS auto merge something in SSIS, which of course never ends well.
Yep. There's a cherry picker, it might be extension option in Azure DevOps. So occasionally when things get a little bit crazy, I create the option to cherry pick. So somebody's pull requested, but I don't want one of their files because it overrides something that needs to stay there, then you've got a little bit of flexibility there. So I highly recommend having that available. The other thing about version control, so it's Git, and you don't control your commits. Basically, in the UI, in the Azure Data Factory Studio, when you save, you are committing. So your commits are very noisy because you're not controlling the message with it. I save a lot more than I would probably commit to a remote repo. And that's okay, that's how it works. It just means that you don't want anything else in this repo. Like if you were even considering putting, maybe you've got a database project or something like that that's related to this data factory, you can put it in the same DevOps project, but put it in a separate repo, because your cadence of how things get committed will be incredibly different when you're manually committing instead of having Data Factory commit every time you save. Let's check for any questions. What's the URL for the blog to grab the slide deck? So the slide deck is not out there right now, but it will be on the DCAC blog. I'll blog it on mine and it'll get syndicated through. So if you just go to dcac.com, and if Denny can grab the URL and throw it in there for people, that will help. And then look for publications, then you'll see our blog. All right. Let us talk deployment. This one I think has been especially painful for people. So first we're going to talk about the ways you can deploy, and then we'll talk about my favorite way. I actually have seen this. I've had to do this a couple times to get people unstuck, but this is not a recommended way to do things. You could just open up both data factories and copy and paste your JSON files. It's very manual. It's kind of awful, but it technically does work. The Microsoft approved way is ARM templates. So you can generate an ARM template in the portal and basically download the JSON for that and then upload the JSON for that to the next environment data factory, or you can write code to deploy your ARM template in a more automated fashion. There's PowerShell or CLI for Azure Data Factory, so you can interface with the service that way. My preferred way is a DevOps pipeline. And so we'll talk about both ARM template and DevOps in a little more detail. So if you're just getting started, deploying via ARM template, it's a somewhat simple way to go because it can be manual or automated. You can read all the JSON in there. The thing that's, if you're used to dealing with like databases, the actual database project isn't inside an ARM template. You're just creating the resource. When you deploy a data factory, it's all your pipelines, your data sets, your link services. They're all in your ARM template. And you can use global parameters. I think those got added maybe last year to change values. So you have a dev data source, data lake, and a prod data lake. You need to change the connection string. You could use a global parameter for that with your ARM template because your global parameters are visible in the ARM template. The downside of that is that your ARM templates contain every pipeline, every linked service, all the stuff. There is no selective deployment, so every artifact gets deployed each time. Another part that bothers some people, and this may be, industry specific or subject specific, is that all those parameterized elements are exposed in your template parameters. So if you don't want the connection strings to be in your activity log when you're deploying, things like that, then maybe this isn't the way for you. What I like is there is a free open source extension called Deploy Azure Data Factory, and I use that in Azure DevOps. The very first time I set it up, it took a little while to understand, but once you've done it once, every time you need it, it's really quick. I mean, like 15, 30 minutes, you could easily get it set up the second or third time. So it is an extension, just like there are extensions for lots of other things in Azure. There's a marketplace for DevOps extensions. So this one is out there, and they actually have a PowerShell library too. So if you prefer deployment via PowerShell, you can accomplish the same kind of thing. I just do it through the GUI because it's quicker for me to set up. So instead of deploying the ARM template, which is generated in the ADF public branch, what this DevOps pipeline would do is actually use the JSON files in whatever branch you've designated from source control. So for me, in my example earlier, I want to use the files that are in main. It also allows me to do selective deployment. So I don't have to deploy everything every time if things didn't change. I could just deploy some new things. And I can change, instead of using those global parameters, I can source control a config file. It's just a CSV file, and I can choose any property that I can identify in the JSON of any file and change that. So when I need to go to the next environment, that all gets changed there. And it includes global parameters. I could change a global parameter in the config file if I really want to. Nice thing is that if I have stuff in the target that's not in source, it doesn't have to be deleted. I can choose whether or not. I prefer to keep things the same all the way through, but if you find yourself having a reason, there are include and exclude lists for deployment, meaning if I have something in dev that's going to the next environment, I can choose whether or not to deploy that file. And then I can choose if I have something in prod that I don't want to get deleted, even though it's not in dev. So we're going to look at a quick example of this, but this is kind of the overall process. So when something gets checked into main, it builds it, meaning it publishes it to the publish branch, and then it gets automatically deployed to test. And then I have a gated deployment to production. So in this screenshot, this is queued because it's waiting on me to approve it. So let's go look at that. So this is in Azure DevOps in pipelines. This is what I've got going on. And this I ran earlier today just so we'd have it ready. And we can see that it's pulling from the main repository. So when this is there, when this gets a new check-in in main, we can see the commit ID that caused this to run. Then it goes ahead, and builds that. When we deploy to test, it's got these steps, and you can actually see all the stuff, but it basically downloads all my artifacts, it validates them, and then it publishes it to the next environment. So I have dev test prod here. You could have, just prod or just, or 4 environments, whatever you want. So here you'll notice there are approvers. Somebody has to approve this, and it's got an eventual timeout. So while I automatically, as soon as I checked in something in dev, went ahead and deployed to test so that my latest code would be there for testing purposes, I'm not automatically deploying to production. Somebody has to approve this. So there was an approval to get it into main in the first place via pull request, and then it got automatically deployed to test. And then it sent me, let me grab my email here so you can see it. It sent me a little notification. So this is continuous integration. It built and it sent me an email. And it built because I committed this link service, which is in a later demo, to my main branch. So you can have it just notify you. You can have it require approval. See if I can find my approval one. There we go. Deployment to stage, deploy to prod is waiting for approval. So then I could click and say, cool, yeah, let's go. And then it would deploy. And it's been pending for about an hour. And now it'll go. So you can control, when whether things need approval, when things go, what the timeouts are. But it's really just these kind of 3 basic steps to get it through this process. And that way I don't have to worry about, is my publish branch out of sync from main in my dev data factory? Or did we remember to deploy the latest stuff so that QA can actually test what we have? We don't have to make those manual. And it also helps with the fact that we said version control needed to be on dev only. When things are automated and gated and approved like this, it makes that process a lot easier. All right, let's see if there are any new questions. Oh, is source control going to be the same for Synapse projects? I believe it is now for the data factory portions. There was a discrepancy, and I think it's either already resolved or about to be resolved. So for this portion of it, yes, you still connect your data factory. In fact, we'll go over here real quick. You connect your data factory to a repo, and then whatever you've connected to shows up there. Let's see. I've kind of already got it connected, so it's not going to be very fun to look at. But yeah, that'll be true whether you are in Synapse or just Data Factory. Next, we can talk about Key Vault.
Yay, Key Vault. All right, if you're just for really quick, if you're not familiar with Key Vault is just a service object, whatever you want to call it, service, I guess, a resource in Azure that is intended to store certificates, any other like text-based secrets, i.e. passwords, in a secure, centralized fashion. Now, that's what Key Vault is. It's really good at that job, shockingly enough. So what this allows you to do is it allows you to store all of your all of your passwords or at least passwords and maybe connection strings in Key Vault separately from your ADF. What this means is, in order to use this, there's a specific Key Vault linked service that you can add to the factory, or you can use a web activity to retrieve credentials that way as well. One of the and for the most part, this is pretty self-explanatory. It's just a way to store passwords that you don't have to worry about changing them and stuff as you deploy or as you promote your data factory to different tiers, as you go from dev to test to production. I've got a situation now where there's a couple passwords that I still have to update. by copy paste when we deploy to production, and it's terrible and no one should do that. One of the other ways that one of the other little more nuanced things that using Key Vault gets you, this mostly only applies when you're in development. But when you're in development, when you do things like update the password on a linked service, when you update that password and hit save, you get a little warning when this happens, but it immediately publishes that linked service, and now you're kind of in this outside of your branch situation with that, and that can get weird. Yeah, there's Meagan's driving. I'm just yapping here. So yeah, there you can see the little link or the little warning that you get when you do that. So that's a real kind of, if you don't think about it, you might not notice that, or might not think about what that means for what's where things are at per se. So also in that screenshot there, you saw where it's just kind of the normal manual connection string setup, and here you see it too. There's where you put in the server name and the username it uses and the password, and that's, we've all looked at UIs like this forever. But your other option is to use a Key Vault to store this stuff instead of basically typing it in here or deploying it when you do promotions. And selecting it's really easy. You do have to have or it uses a managed service identity to authenticate to it. But once you have that configured, it's just a matter of picking the Key Vault and then the typing in or choosing, depending on if you're, depending on which option you've selected there. You're selecting the Key Vault and then the name for the secret to use, and you're done basically. And then that gets, just that configuration then gets saved. And as you do promotions, as long as the same name is there and stuff, it'll just work. One thing that isn't necessarily evident, and this is about the only thing I don't like about Key Vault. I don't think this is Meagan's primary reason for pushing Key Vaults to be separate for each tier along with the data factories. But one of the things that really gets me is, and this is just in general, not necessarily an ADF only thing. If you're not familiar with Key Vault or haven't looked at it before, Key Vault has no hierarchical organization in it. There's no concept of folders. So if you have, or you try to, did it once, never again, or try to have one Key Vault for, like, say, your whole environment where you've got dev and test stuff in there both, basically the only way you can separate things is by their name. And that basically just leads to kind of pain and not fun. Here, Meagan's got it. I'm not even looking at the right screen. Meagan's got it open here. You can see basically your only option is to create a new secret, and that's it. There's no folder or other objects there.
Yeah, I'm just going to show so this is my
control.
Managed identity. So it has permissions to get and list the secrets. I think it could just be get for this demo, but that's what I've given it. So this is all you have to do, is go in here and add an access policy, or use the IAM stuff if you want to do that instead. But that's it. That's how you grant access to your Key Vault from your data factory.
Key Vault has super specific, you kind of could get a glimpse of it there, super specific access control to access the secrets stored within it, almost to the point of it potentially being very tedious. But that's one of the good things about it is you've got very specific and precise control over who can do and see what within Key Vault.
Yep. Okay. Integration runtimes. So I've seen, and I blogged about this on Data Savvy a while back. People are a little confused about when they need an integration runtime. So we're going to talk about 3 types. We have Azure integration runtimes, self-hosted, and then SSIS. So if you need to run SSIS packages and call them from Data Factory, you need an SSIS integration runtime. you have a default built-in Azure integration runtime, but that doesn't mean you can't create more. And then self-hosted is often needed to get into private networks. So let's talk about that one first. Lots of people don't realize when they're setting up their first data factory that you need a self-hosted integration runtime to get into any private network, even a cloud network. So let's say you're pulling data from a SQL server inside a virtual machine in Azure, so IaaS database. That requires you to pierce through that VNet, that private network, to get the data and pull it out. Therefore, you need a self-hosted integration runtime. It is your compute. It is how you execute queries, how you convert. Let's say you're pulling data, converting it to a Parquet file and landing it in a data lake. It needs the resources available to actually do that work. So give it cores, RAM, everything that it needs. It is recommended that you give it 4 cores, 8 gigabytes of RAM, and 80 gigabytes of available hard drive space, just as a started recommended minimum. So, don't forget, it's actually doing work there. It is also possible to share integration runtimes. I don't recommend it necessarily for production unless you just have a bunch of smaller data factories, but I definitely recommend it for, let's say you have dev, test, and prod, share your integration runtime for dev and test. That way you don't have to set up 2 of them. So it means you have to have a virtual machine, and then you have to go and install this IR and associate it with your data factories. People don't always plan for all of those virtual machines. So sometimes in lower environments, it makes sense to go ahead and share your self-hosted integration runtimes. If you're going to do that, make sure you size it appropriately. Whether you're in dev or prod, if you're going to share, be aware that you may have, 4 data factories using this one IR, and make sure that if they're running jobs at the same time, they have enough resources to do that. And then my own personal nightmare from several years ago, but make sure all the libraries you need are installed and updated. So years and years ago, I was working with a client using Data Factory, and everything worked great in dev, and we were getting ready to deploy to prod. We deployed and nothing was working. I think we were querying a database on-prem and converting the data to ORC files and landing it in a data lake. Great, except it was throwing an error and saying it couldn't do that. Well, we checked and we couldn't figure out, what was going on. We had the Java runtime, that was fine. It turned out in dev, we had installed Management Studio on that VM that was running the self-hosted integration runtime so that we could do queries to check the data that we were pulling into the data lake. But we didn't install Management Studio in production. Well, when Management Studio gets installed, it installs the Visual C++ 2010 redistributable, which we had not installed in production because no one told us we needed it. It is now well documented. So if you run into this and you look in the docs, it will tell you that you need it. My issue happened before that, but just take note if you have specific drivers because of the data source you're connecting to. If you have any of that, not only do you need to make sure they're there in the first place, but don't forget about them and update them as new releases of those drivers come out. So that was self-hosted. Let's talk about Azure. We use Azure integration runtimes when we're copying from cloud to cloud store. So this might be, database to data lake or blob storage to other blob storage. It also gets used for data flows, so the transformation piece that's available in Data Factory. It auto scales, so you don't provision a size necessarily when you're just doing copy activities. What you do is you build a pipeline with a copy activity, and then you tell it how many data integration units you're willing to use, and it will scale appropriately. There are two kinds of Azure integration runtimes. There's a default, and you'll see it labeled auto resolve, but you can also provision an Azure integration runtime. And I recommend that because when you provision it, you can tell it the exact region to put it in. So if you have regulatory things that say your data cannot leave this region, you've got it covered, but also because it keeps things very clear if there are questions about data egress charges. If you use the auto resolve, it will spin it up closest to your data or in the region of the data factory. So it may or may not be the region you wanted it to be, and it may cause you to have some egress charges that you didn't want. So if you provision it, you know exactly where things are going to be.
And just for a note, provisioning, I know when I'm talking about Azure stuff or someone's talking to me about Azure stuff, you say provision and versus something not provisioned. That always makes me like, okay, wait, am I gonna have to pay for something more than when I'm using it because I've now provisioned it, right? Am I gonna have to pay for some VM to sit out here all the time? And the answer to that is no. The charge is effectively the same. Well, Meagan, is it safe to say effectively the same, or it is the same if you were just using the integrated runtime?
The auto resolve, it would be the same.
It's the same. Okay.
The only difference is if you're doing data flows and you set a time to live, which is our last point. So let's say you have a pipeline that ends up executing 10 data flows. You don't want it to spin up lots of different IRs. You may just want to use the same one and keep it alive because there's a time cost to waiting on something to spin up. So you can set time to live when using data flows. And let's say you put it at 1 hour or something. Well, if your data flow is finished in 20 minutes, it's still, you're going to get charged for the minimum of the hour. So just be aware. Sometimes that's what you want to make sure everything runs really quick, but there's always a cost trade-off. All right, parameterization. Actually, before we do this, there are a couple questions. The first one was, have you run into the 256 parameter limit? How do you get around it? I think that was in regards to deployment via ARM template, and feel free to comment if it's not just about that. I have not personally hit that, but again, I'm not parameterizing my ARM templates anymore. So I don't know that I don't think I have anything that has 256 different changes in my config files, but that's a good thing to test. Maybe I will note that down for a blog post later. Somebody else has asked, do you recommend installing the integration runtime on your database server? I've seen it done, but remember that you're sharing resources now. If it's especially production, I really, really, really wouldn't do it. I've seen some people do it in dev and I cringe a little, but it works. And the reason why people do that is because they don't want to pay for another VM, a separate thing that has to be in that network just to get Data Factory access that it needs to the data. And I get it, the VM costs money. It needs to be, like we said, decently beefy. It can't be really, really tiny because it's actually doing work in there. But I wouldn't do it on your database server if you can help it. Just because if somebody queries your database server and it's using up a bunch of memory and Data Factory is running there, you could run into resource contention. And I don't want to bring down a production server because of the Data Factory integration runtime, I guess is what I'm saying. If you want to save money in dev, okay. It's hard for me to say to do it in test because I think you should be performance testing there. But I guess that's kind of up to your organization, how much testing. If it's really small stuff it may not be any different. If you've got the world's beefiest server and it's got room, I guess I don't have a good argument for you not to do it there. But in general, this is kind of like when people ask me, well, should I put analysis services on the same box as my SQL database? In general, no, because you have resource contention. If you can't help it, will it technically work? Yes. One thing to note, though, is I can't remember if it physically blocks you or if it just makes things really unhappy, but you shouldn't put a self-hosted integration runtime on the same machine as a Power BI on-premises data gateway. And it's actually documented saying don't do that. So I see how it gets very easy to rack up a bunch of VMs for all these gateway type things. All right, we're going to get through the last couple topics real quick. Parameterizing your data factory. We have already mentioned global parameters, so they sit kind of at the top level of your data factory, but there are also pipeline parameters and data set parameters and linked service parameters. So the deal for me is you absolutely, want to parameterize your data sets. So a data set is pointing usually to a file or folder or a table that's connected to a linked service. So we'll do databases as our example. You have a linked service that points to an Azure SQL database. If you design this very literally, and let's say you're going to import data from 5 tables, you could have a data set per table. But you could also just do one data set that's connected to that linked server for your SQL database and parameterize it so that you can pass in the name of the table or view as part of your pipeline, as part of your copy activity. So I think data set parameterization is very important because otherwise you get an explosion of JSON files that becomes unmanageable if you have a decent sized data factory doing a lot of stuff. It could depend as far as your link services. There are some good cases for having a more generic link service. Like I have one client who they connect to multiple instances of the same API. So it has like a different URL, but it's the same type of data, the same calls get executed. Then we have one link service. But in general, that can decrease transparency to see what you're connecting to. So if you're just getting started, that may be less helpful. So I'm kind of okay with just having one link service per data source, but definitely parameterize your data sets. Global parameters get used for connection information, secret names, stuff that changes from one environment to the next. They become less important if you're doing the DevOps thing since you have that config file, but you could still do it there. If you're deploying from JSON, global parameters should be required. So this is just an example. I'll actually flip over real quick and show you this data set. This data set is pointing to blob storage. And so what you'll see is I've parameterized the container, the folder, the file. If this were a database, I could parameterize schema, table, whatever I want. I can parameterize the query that gets executed in a copy activity as well, or the stored procedure. So how this works is we define parameters here, and then we go back to the connection and we reference those parameters. And then when this gets used, we reference the parameter there. All right, comments and documentation.
There's a question that you should grab, Meagan.
Oh, okay.
That is actually a really good point, and I've never thought of that particular nuance before.
Doesn't it make it easier during deployment to use a shared IR? It could make it easier because in your copy activity, you're specifying an IR, but I think you can You could have the same name for an IR in a different environment. You could use that parameterization to change it as you deploy. So it does, you just have to balance that out with, am I going to run into performance problems with resource contention or network or anything like that?
All right, so let's talk about another one of my favorite pet topics, which is documentation. So this is pretty easy, and which is good because we're out of time already. So the main idea is document stuff, write stuff down, help the next person in line. The big thing here is, even though this is JSON, and I kind of talked about how nice and clean all this stuff is because it's just JSON in the background or behind the scenes, you can't just go back there and throw comments right in it for any number of reasons. So you can't do that. But ADF gives you a bunch of built-in stuff where you can leave words for future you or future others. You can add descriptions to basically everything: pipelines, activities, link services, even the IR config or the IR metadata. It's there in the factory. You can add just plain old descriptions. Obviously, it's a good idea to do that. We recommend that everywhere, even if it feels a little hokey. That's the easy stuff. In addition, there are things called, there are two other things. One of them is annotations. So annotations are basically little single string bits of words that you can add to pipelines, data sets, linked servers, and even execution triggers. You can put these little annotations there, and they're just plain text. You can put in whatever. It's not a key value pair. It's just one element. The good thing about these annotations are they show up in the monitor. So in the monitor page in ADF, where you can see your execution history and such, you'll see those words there. So that's one of the cool things about annotations specifically. In addition, there are user properties. And these are key value pairs that you can add to pipeline activities. So even not the pipeline itself, all the work, the activity objects that are there, that are in the pipeline that do the work. Those are just another kind of layer down of where you can add your own words to add some documentation. Other ideas, moving kind of beyond to a larger scope or a bigger idea, just further documentation. We've talked about how a lot of this stuff can be integrated into Azure DevOps. That's where the Git repos are for this stuff. Right there in Azure DevOps, in your project, is a wiki, doohickey that you can use. This is not the most feature-rich wiki product on earth by any stretch of the imagination, but it's right there with your other stuff, which is why I like it. So it's great. People are probably already there, whether it be you the developer, or if you're on a Scrum or Agile team, and you're using DevOps for your task boards and stuff like that. People's eyeballs are kind of already there, so it's real nice if you can be like, anybody has a question about functionality or what data sources are involved, you can just be like, the wiki right there, the button, push it, and stuff is there. And in addition, large commits, or when you're making big hunks of changes, write up some stuff about that specifically. You can use commit messages for this sort of thing, right? Or words in a pull request that you're pulling into the main branch. But it might be a decent idea as well to pull that text out into somewhere else outside of the repo, especially for non-developers, non-technical users. It'll be easier for them to find info like that, or dates when major things happened, if you've got that stuff written down somewhere else.
All right, we are on our last topic, and we'll just make a couple notes here of things to pay attention to. And the first is pipeline hierarchies. Basically, we're trying to make our pipelines reusable. So it's pretty common to have 3 to 4 layers of pipelines, and you saw that in my screenshot earlier. And what I do is do orchestrator, executor, worker, and utility. So your orchestrator, if you think in SSIS terms, is like a master pipeline. It's the thing that just runs everything else. My executor might be, let's have a lookup that gets some metadata information and then runs into a for each loop. And in that loop, it executes the worker pipeline. And then utilities might be things you just need to use all the time. Maybe it sends an email when something fails or finishes, or executes a stored procedure to log data to somewhere else about the load. Anything like that that's kind of generic is the utility worker that might be reused across different purposes. You need to know, I have a whole blog post about this, and I'll show you the PDF in a second. The way you do error handling in ADF and the way you need to understand notifications is a little different if you're not used to this environment. First, it has retries set on pretty much every activity, so you can handle transient errors. No reason for the whole thing to fail if you could retry it 5 seconds later and it would work. You want to set your timeouts. The default timeout, I think, is like 7 days. So you probably don't want something running in dev for 7 days costing you money. You may need to lower that. Maybe you want it for a couple hours. Maybe it's, 1 day is acceptable in prod, but definitely go change those defaults. And then you need to log your errors in a way that makes that information usable. So sometimes that means, in addition to the ADF monitor, you send your data to log analytics. Or sometimes within your pipelines, you log additional data to other databases, and I do that pretty frequently. The big thing is understanding when a pipeline fails and how Azure Monitor would let you know what's going on. So I'm going to switch over to this guy. Here's the thing, just because an activity in your pipeline fails doesn't mean your pipeline will fail. So if I have an activity and it's got a failure dependency, so activity 1 fails and activity 2 succeeds, my pipeline's going to report success. Same thing if it's completion. So you can see there are a bunch of variations here. Let's say activity 1 fails, and now there's a success dependency and a failure dependency, then my pipeline reports failure. But if we go back up to the kind of try-catch pattern here, activity 1 fails, activity 2 succeeds after the failure dependency, it's success. So you need to understand how you want to build so that you can monitor appropriately. Sometimes I have to monitor on specific activities. I could also do things like force my pipeline to fail using a bogus web activity. I've had to do that a couple times to make sure that the pipeline actually failed the way we needed it to, but first it logged information to a database. So just be aware that an activity failure does not always mean a pipeline failure, and you can go and find this PDF. So that brings us to the end in this recording, or if you get the slides, you can grab these links. So we've got the Cloud Adoption Framework that talks about resource naming. It's a good resource to read through in Microsoft Docs. The Data Factory naming convention for pipelines, data sets, all that. The pipeline hierarchy. So I use different names than Paul Andrew, but his idea is really the same. And I kind of learned how to think about this from him. And then the ADF tools from SQL Player, and then the PDF I just showed you about failures and pipeline outcomes. So we hope you enjoyed this webinar and that you got some useful information out of it. We are always happy to help you set up your data factory if you're just getting into it, or do health checks on your existing data factories. Please let us know if you'd like some assistance from us. And thanks for joining us.
Thanks, everybody.